Doing a video today on how to verify if you have a warped brake rotor. Now, the idea of the rotor is it spins on your wheel like so. Now, this is an old rusted up rotor and everything. I just set this up for this video. But as that rotor spins, and this is the steering knuckle attached to your vehicle, so as this spins, the brake caliper out here should be running free, not really touching this at all, and in that are these brake pads. So as the brake pads, they're inside the caliper, they'll come down as you hit your brakes and force against them, and the friction of these pads will cause this to stop spinning. Now what will happen is, if this rotor becomes warped, and causes of that can be just natural wear, or sometimes you might be driving along and say wet road conditions, this might be wet and you'll hit the brakes, and because of the heat that builds up and the moisture on the rotor, sometimes it will warp. So what will occur then, and of course I'm not saying be careful not to brake in wet conditions, you're going to use your brakes to whatever safety you have to, obviously, but that is just something that can happen. And once this rotor warps, it'll be spinning in here, and it shouldn't be really touching this caliper, just very lightly, the pads within the caliper. But if it warps, it'll be uneven. So actually, nice if you can just move over here a little bit. So as this spins, then what's going to happen is the pads are going to be here, and because this isn't an even width anymore, it's now warped, it's going to be spinning and forcing the brake pads in and out. And that's going to cause, when you hit your brakes, as this spin and as the rotor spins, and as I say is now uneven, it's going to cause a pulsating feeling in the brakes. And we're going to go for a little drive in a vehicle that has a warped rotor, and I'm going to show you what that feels like, and hopefully you'll be able to see in the video that as I hit the brake and that warped rotor, which should be spinning straight within the pads, is now spinning unevenly, forcing these pads out, and it has feedback in the brake system. So hopefully it'll be able to show in the video that my foot as I hit the brake actually comes up and down. So now that we discussed the basic operation of a caliper and a brake rotor and how the rotor spins with the caliper kind of hanging outside of it, ready to press the brake pads against the rotor, I'm just going to take this vehicle for a little drive here. We can see that my fingers are steady on the wheel. There's no vibration in the vehicle itself as we drive along here. Now, don't try this if you're on an area where there's any traffic. Obviously, be very safe about the whole thing. But I'm going to hit the brakes. Now you can hear that and hopefully see the vibration that's in the wheel when I do. Another little test I'm going to do, and again, make sure there's nobody behind you or for a good distance in front of you. I'm sitting here idling, and I put the vehicle in neutral. Basically what we want to do is make sure that there's nothing else that might be sticking in the brake system to cause this. Now hopefully you can see this. I have the vehicle in neutral and we're just rolling along here. So, and I'm on a very slight grade, so there's nothing else sticking to cause this vibration when we hit the brakes. And the wheel is nice and straight ahead here. No vibration on the wheel until I touch the brakes. So I'm hoping there's enough lighting down there to catch my foot on the brake pedal. And again, driving along here, making sure there's no traffic in front or behind me. And I'm going to hit that brake pedal. Get a little exhaust problem here too. Hopefully you can see that I'm keeping a steady pressure on my foot. But as the rotor turns within the caliper and the pads press on it, I'm actually feeling a pulsating back from the brake system. Okay, this vehicle at the moment is jacked up, it's in neutral, and it's blocked. Now this is not something that you want to do unless you're absolutely sure that you have it done safely. So I'm not recommending this, but I just want to show This is an example of a severely warped rotor here. So, because it's in neutral, I can spin this tire, and hopefully this will come out in the camera. If you can see, it becomes really tight at one point here. So tight. The reason that is this rotor is so severely warped that as I get to that point, the pads, that rotor is basically warped thicker than normal. It's hitting against the brake pad. So, as I say, this is just for illustration purposes. And that's the point right there. I actually have to really come onto that. And then it'll get past that point, and then it spins, and then it hits that point again. So that's what happens with the warped rotor, and that's why you feel the pulsation in the brakes. So I have replaced the rotor. I'm underneath the vehicle here now. You can see the new rotor right there by my finger. Probably should have taken a shot of that before I put the wheel back on, but I didn't. But anyway, there it is. Okay, as we said, the new rotor is on. I started the vehicle. I hit the brakes a bunch of times with the vehicle running so that the full force of the braking system seated the pads on the rotor. Now, we can see I can spin this. Now there's no uneven points because that rotor is not hooked. Now we'll take it for a test drive. So, vehicle with the new rotors, hit the brake, nice and solid, no pulsation. So, the issue there was the warped rotors.